Hello and welcome to this video of Python 3 programming. In this part we will learn about integers and floats and some mathematics functions, particularly math and complex math functions. But to learn it is best that you install BPython, which is an interactive Python shell. So if we have the virtual environment activated, which we have created in last part, you can simply say pip install BPython. I'll get installed. You will need internet connection, of course. I have already installed, so we now invoke the BPython shell. You can get help by pressing F1. So C stands for the control key and M stands for the meta key, that is typically Alt or Escape. Okay, so as you know, Python is a dynamic programming language. That is the type of the variable is determined by the value contained in that. So if I say this x is equal to 4, then it is of class integer type, and if it is 4.5, then it is of type float. Now let's see what we can do with integers. We can add them, we can subtract them, we can divide them, we can of course multiply them. We can also raise a power. 2 to the power 4 is 16. By the way, I apologize if you hear any horns in the background because I live in a very noisy area. So we have that. And now we can do various other things. For example, compute modulus 5 percentage 4. You can do these operations with floating point operations also. So you can subtract them as well. You can divide them, you can multiply them, or you can get a modulus also, or you can compute power also. Fractional power also works. Now you can do various other operations. For example, you can test for equality. So there are two Boolean variables, true and false in Python. So you can convert, any integer to Boolean or any float to Boolean. Now apart from 0 and 0.0, all other integral and floating point values are true. You can test them for inequality, and you can test them for greater than or greater than equal to, less than equal to. This will also work for floating point variables, except to be very careful when you test them for equality. Very close values will lead you to wrong results. For example, in this case, this happens because if you understand that floating point numbers are very hard to represent in binary, so they have to be truncated after a certain point, which is governed by the floating point specification IEEE 754, I remember, if I remember right. Now we have tested this. Now if you want to do bitwise operations, then you can do bitwise AND, bitwise OR, bitwise OR, and you can get 2's complement. You can do logical AND. The value will be the last value. It's a short circuit evaluation. So if a 0 is encountered, then it won't evaluate further, and 0 will become the value of entire expressions. You can do OR expression. So in this case, it will try to find one true value, and once it is found, that will be the value of expression. In this case, 2, or it will try till it does not find true value. So in this case, it could be or this case it will be 2. 0, 0 will be 0. Um, for floating point numbers, you can compute ceiling in float. You need to import math.floor. If you take for integral, then it will be always same, floor and ceiling. But for in, floating point numbers, it will be different. So floor will be less than that, and integral ceiling will be the next integer. Floor will be the previous integer, and ceiling will be the next integer. You can compute absolute value of an integer, so that will remove the sign, and you can compute this for floating point numbers also, absolute value. So if you see, there are lots of functions available in math module, and similarly there are lots available in CMath, which is complex math. We'll see complex mathematics later. What more we can do? We can convert an integer into binary, and you can't convert floating point numbers into binary, by the way. And you can compute hex of any integer. You can convert octal of any integer, which is the base 8 representation. And you can't do this for, I believe, floating point numbers. Okay. So these are the basic functions you can do, not functions, functionalities which you can use with integer and floats. And these would be the most common ones. And now about printing, if you want to print an integer with say a string, then you have to, for concatenation, you have to convert it to string. Or the other way to do that is you can use the comma part and print the same. Same applies for the float also. So I believe I would stop here. If you are really interested, then you can have a look at integer class. So these underscore absolute functions are overloaded operators. So you can read these, and you can read the same for float also. So this is how you apply operators on that. Okay, by the way, and the hex function is available for float. You have to do float.hex. So for example, I can say float.hex, and it will give me the floating point representation in hexadecimal. So I believe I'll stop here, and in my next part I'll deal with strings. Thanks a lot for watching the video. And if you like this video, then please hit the like button and subscribe to